Hello guys, welcome back to my YouTube channel. Yeah, this is Dr. Kimani, and today we are going to cover a prediction of KCSE 2024 Chemistry. So kindly, before we start, remember to subscribe. The subscribe button is the one below this presentation. Yeah, it's just below there. It looks like a bell. Subscribe, share, and comment if anything you want clarification on anything, please. Yeah, so let's get started. So this is the paper you're going to do today. It's a paper 1 chemistry, and it covers several questions, as you can see. So from the several questions, we have like 25 questions. And now for the sake of you guys, I know at times you need to see the written answers themselves. I've taken the liberty of preparing another presentation or another paper, which has both the question and the answer. So this was just to show you what we are going to cover. So we are going to use the one that I've answered. Yeah, so let's get to the one that I've answered so that it may be convenient for you. So guys, here is the answered paper of the version of the other one, chemistry. So without further ado, let's get started. The first question now asks, and okay, remember this is a KCSE prediction, so it probably cuts across from Form 1 to Form 4. Yeah, so generally we are going to cover several topics. Enough for the first question. We have been asked to state Boyle's law. You remember this law, yeah? Now, for Boyle's law, Boyle's law is the law that states that the pressure of a given mass of a gas is inversely, mark this word, inversely, the pressure of a given mass of a gas, the pressure of a given mass of a gas is inversely, I want you to mark this word, inversely proportional to its volume at constant temperature. Mark those two words. Inversely proportional to its volume at constant temperature. And this makes sense. Why? Because if you take a case instance, if you have let's say a balloon, yeah? When you take a balloon, the balloon has a given mass of a gas, obviously. When you inflate the balloon, not to its maximum, but just inflate it. Now, if you inflate the mass, the balloon, that gas will have a certain mass. And now, when you decide, sorry, so let me come again. Boyle's law states that the pressure of a given mass of a gas is inversely proportional to its volume at constant temperature. So now, what do I mean? Is that when you have a balloon, and you decide to inflate it, and now then you decide to, compress it, and leave a small opening. Remember, air will be leaving. As air will be leaving, the balloon will be decreasing in volume. So what will be happening to the mass? So the mass of the balloon, as you can expect, will also be reducing. But now for this case, we are discussing about the pressure now. The pressure of a given mass of a gas is inversely proportional to its volume at a constant temperature. Now here we are. That was about the mass and the volume. As the volume decreases, well, the mass also decreases somehow. But now when you talk about the pressure of the gas, that's the Boyle's law now. The pressure, when you take the balloon, inflate it, and now, while it's inflated, you compress the balloon. Don't leave an opening. Compress the balloon. If you compress the balloon, when the balloon will be reducing in size, what do you mean? Reducing in size or reducing in volume? But when you reduce in volume, what's making the volume to decrease or the size to decrease? Because we are increasing pressure. So the more you increase the pressure, the more the volume decreases. That's why we are talking of the volume of the gas being inversely proportional to the pressure. But this can only happen at constant temperature. Why? Because assume you are applying pressure, and now the volume will be decreasing as well. That's obvious. When you apply pressure, when you increase pressure, the volume will be decreasing. But now, if you decide to change these conditions of temperature, let's say as you are compressing it, the volume is decreasing, but then you decide to hit the balloon, what will happen? Remember, when you hit air, it will expand. So instead of you seeing the volume decreasing, it will be somehow increasing. That's why you have to keep the temperature constant. So that's about it about Boyle's law. Just remember pressure and volume, PV. That's why even the law for the Boyle's law in a simplified version, you just say P1 V1 equals to P2 V2, because why? The temperature is constant. You won't expect to see temperature in the equation because it's a constant factor. Temperature here is same as temperature here. So we are dealing with pressure and volume, which are inversely proportional now. Now we have a question on Boyle's law here. At 400 degrees, 850 centimeters of, or 850 cubic centimeters of a gas exert a pressure of 560 millimeters of mercury. What volume of same gas would exert a pressure of 6040 millimeters of mercury at the same temperature? Now, whenever you are working out these equations, remember always to use the same units. For this case, we have centimeters. So what we expect here, volume will be in centimeters. And now we are using degrees Celsius. Okay, temperature is a constant factor here, so you need to include it in our equation. But for the pressure, we are using milliliters of mercury. Make sure you calculate with the millimeters of mercury on the other side. So now using Boyle's law, P1 V1 equals to P2 V2. Just get this one, and then you'll be at a good place. So pressure 1 is 560 millimeters of mercury. Volume 1, we have it as 850 centimeters cubic. And now for pressure 2, we have it as 640 millimeters of mercury. But what don't we have? We don't have the volume for 2, yeah? And now, before even we do the calculations, guys, I want you just to reason out here. Because if at this point, pressure is 560 milliliters of mercury, and at this point, pressure is 640. What does this mean? We have increased the pressure. So obviously we expect the volume to be lower because assuming it's a balloon, we've compressed more and more, yeah? So the volume will be decreasing because temperature is constant. Now, if you take this instance, now we have to work out for V2 now. So P1 V1 equals to P2 V2. That's 560 times 850 equals to 640 times V2. Now to get V2, you have to divide both sides by 640 here. So that's what you have here. 560 times 850 divided by 640. That gives you 743.75 cubic centimeters. Now for question number 2. When burning magnesium is lowered into a gas jar containing nitrogen 1 oxide, it continues to burn, forming a white solid. So guys, you see it's a burning magnesium and it's lowered into a jar containing nitrogen 1 oxide and it continues to burn, form a white solid. Now, I want you to remember that what causes burning? For something to burn, there must be oxygen. And now we've lowered burning magnesium. Remember, burning magnesium burns at very high temperatures. Magnesium itself burns at very high temperatures. So magnesium, guys, is one of the things that burns at very high temperatures. So it burns at very high temperatures. What happens to nitrogen 1 oxide? It will like kind of separate this nitrogen oxide into nitrogen and oxygen. You know, high temperatures, it will break the bonds of nitrogen 1 oxide. Yeah, that's such that will be remaining with the nitrogen gas and oxygen gas. Now the oxygen gas from this nitrogen 1 oxide, it will support burning of magnesium. That's why it continues here. As you can see, it continues to burn. Well, you would have expected it to stop burning because there would be no oxygen. But now it have decomposed. Okay, it have broken the bonds between the nitrogen oxide to form oxygen. The oxygen supports further burning. So magnesium will react the oxygen to form magnesium oxide. So that's it. So you are being told to name the white solid. So the white solid is magnesium oxide to react with oxygen. Magnesium plus oxygen equals to magnesium oxide. Now, write the chemical equation for the reaction that occurred. We said magnesium reacts with nitrogen 1 oxide. Now, magnesium oxide will be formed because it reacts with oxygen, and nitrogen gas will be released after bonds being broken. Now, number 3, carbon dioxide is one of the gases used in fire extinguishers. State any other possible use of carbon dioxide. So, apart from being used in fire extinguishers, you also use carbon dioxide in carbonated drinks or preservation of drinks. Yeah, I remember when you open a soda, all guys, you have taken a soda, obviously. When you open a soda, there's that whizzing sound that comes out. That's carbon dioxide that is used in preservation. Now we go to the next part. Name any two reagents that can be reacted together to generate carbon dioxide. Two reagents that can be reacted together to generate carbon dioxide. There are many reactions that can generate carbon dioxide. Now, in this case, I want you to remember the topic of acid, bases, and indicators. Acid, bases, and indicators. Remember I said that if you react a carbonate, here we have a carbonate with an acid, the results will be a salt here, carbon dioxide, and water. So generally we have carbon dioxide. They just wanted one reaction that can generate carbon dioxide. So whenever you have been asked to write a reaction that can generate carbon dioxide, just recall anything, any reaction that you've ever run that can generate carbon dioxide. In this case, I've used the calcium carbonate to demonstrate. So if you react a calcium carbonate with hydrochloric acid, you'll have a calcium chloride as the salt, carbon dioxide, and water. Now, next on to the next question. Rusting is a process that causes massive destruction of iron structures. State one condition that can accelerate rusting. State one condition that can accelerate rusting. So now, remember we said conditions for rusting, as you can remember, guys, it was moisture or water and oxygen. Those are the necessary conditions for rusting. So either you add any of those, you mentioned presence of moisture that will accelerate rusting, or presence of oxygen will also accelerate rusting. So now state one advantage of rusting. So here are guys. Well, everything rusting, well, it has many disadvantages, but also everything, almost everything that has a disadvantage has its advantage as well. So the rust layer formed can provide some protection to the underlying metal from further corrosion. Remember, rust is a layer of hydrated iron 3 oxide. So that layer will prevent further corrosion of the metal inside. Can give you another advantage of rusting is that rusting leads to decomposition. Remember when metals, they fall into the soil. If there was no rusting, they would decompose. They'll be like that. But now due to rusting, they'll decompose. And remember that is iron. Iron is the one that rusts. So when they decompose, they will be adding nutrients. They'll be adding nutrients to the soil. That's another advantage. Now let's go to the next question. At 60 degrees Celsius, the 8 grams of lead nitrate saturate 56 cubic centimeters of water. Determine the solubility of lead nitrate at this temperature. So now this is a form 4 question, solubility, topic for solubility. Now, we have been told at 60 degrees Celsius, that 8 grams of lead nitrate saturate 56 centimeters of nitrate at this water. So first of all, whenever you want to tackle a question of solubility, you have to determine, know that what is rusting, not rusting, sorry. What is solubility? So solubility is basically the number of grams of solute per 100 cubic centimeter of solvent. So that's about it. Now we want to determine the solubility of lead nitrate. Well, in this case, we give them solubility of lead nitrate, but in 56 centimeters of water. So the easiest way to calculate this one, you can say if, I think I should write this one for you guys. Let me see. Let me just write it here for you guys. Let me create a space so that I can write it in another way for you, a better way to understand. So if you say if that 8 grams, saturate, saturate how much centimeters cubic of water? 56 centimeters cubic. Okay. Let me just rework that one. Saturate 56 centimeters cubic. So you say, what about we want in 100? What will saturate 100 centimeters cubic of water? So this being the equation, now remember you have to do cross multiplication. I'm sure you know about this cross multiplication. Let me show you. So cross multiplication, this one you multiply by that, and that one you multiply by that. So something of the sort like that. So 38 it will be, basically now it will be 38, we have 38 times, so let me put into brackets, 38 multiplied by 100, close the brackets, then you divide all of this by 56. And that's what you have done here. 38 times 100 divided by 56. That gives you to this one here answer. Sorry. This answer here, 67.86 gram per 100 centimeters. That's the solubility of lead nitrate solution. Now, let's go to the next part. Explain. Okay, let me erase this one first. Explain why molten sodium chloride conducts electricity, but solid sodium chloride does not. So think about it. It's the same substance, sodium chloride, but when in molten form, conducts electricity. In solid form, does not conduct electricity. Why? It's because in molten sodium chloride, we have mobile ions. You know, the ions can move from one place to another. Okay, they are mobile basically. So they can conduct current. But for solid sodium chloride, they are in fixed state. So you don't expect them to conduct current. So here is the answer. Molten sodium chloride conducts electricity because its ions are free to move and carry charge. Solid sodium does not conduct because its ions are in fixed, rigid, lattice structure and cannot move. So a polymer, the next question, a polymer is presented as this one, polymer. Remember, this is organic chemistry. So this is a polymer. And now you have been told to name and draw the structure of the monomer. So how will be the structure of the monomer look like? So the structure of the monomer will be, let's see, so it will be this one. It will be how many hydrogens? Two. We have two carbons and how many hydrogens? 1, 2, 3, and then plus this 3 here. Okay, we even have sorry for this. This was is not correct here. Let me write you the correct monomer here. That was a mistake. Let me delete this one. So now the monomer will be CH2. For this one, as you can see here, CH2. Then you have this other here and here. CNH 1, 2, 3, 4. CH4. So that's the structure of the monomer. Now we have been asked what type of polymerization occurs in the above case. So this type of polymerization is addition polymerization. And then given that the molecular mass of the polymer is 25,620, how many units of the monomer make up the polymer? Okay, sorry. I see where the issue was. So for this one, is the drawing that's the problem. It's supposed to be here. Wait a minute. It's supposed to be. It's supposed to be just a H. This one here. You don't have such a monomer. this is supposed to be H, is the drawing that was done wrongly, because if you come to the calculation, it coincides with the thing. So now the drawing was correct here. Is the drawing of the polymer is the one that is wrong. So the monomer is ethene C2H4. Now, what type of polymerization occurs in the above? Remember, now we have the addition polymerization. Now, given that the molecular mass of the polymer is 25,620, how many units of the monomer make up the polymer? Number of monomer units, 25,620, over molecular mass of, okay, if you want to know the number of monomers, is basically we divide the molecular mass of the polymer divided by the molecular mass of the monomer. For the molecular mass of the monomer, you have to calculate now C2H4. C is 12 carbon molecular mass. So all molar mass of carbon for carbon, C is 12 times 2, 24, plus H is hydrogen, has 1, times 4 is 4. So 24 plus 4 gives you to 28. If you divide 25,620 divided by 28, that will give you 915 units of the monomer. Now for the next question, a reaction can be represented as, now this is ethene again, ethene plus hydrogen bromide give you to C2H5Br or bromide. I've been given the body energies, and now you're being told to determine the heat of formation or enthalpy change. So for calculation, you have to take the enthalpy change will be the bonds broken minus the bonds formed. Energy in bonds broken minus the energy in formation of bonds. So now we are breaking how many bonds? These bonds here. One carbon-carbon bond and one hydrogen bromide bond. They've been given the bond breaking energies here. So now the bonds formed will be forming one carbon-carbon bond and one carbon hydrogen bond and one carbon bromide bond. So then there'll be change will be bonds breaking minus bonds formed. For bonds breaking, it's 580 plus 396 minus bond formed 446 plus 20 plus 438. That's for this one, and this one. It will give you 72 kilojoule per mole. Now define the term dynamic equilibrium. So for dynamic equilibrium, what's dynamic equilibrium? So this is a state of reversible reaction where the rate of forward reaction equals the rate of backward reaction, such that if you have a reaction, it reaches a point whereby the forward reaction and the backward reaction, they are occurring at the same rate. Now we call this a state of dynamic equilibrium. Why? Because any of the products or reactants can be formed at this state. It's the dynamic equilibrium. If you alter the conditions now of a dynamic equilibrium, now that will now be determine which product will be formed here. Now let's see. A reaction at equilibrium can represent, now we have this one here, a reaction at equilibrium. Chromite ions plus hydrogen ions give you chromium 7 ions plus water. Now state and explain the observation made when sodium hydroxide is added with the equilibrium mixture. Remember at this point it's equilibrium, as you can even see the arrows here, shows equilibrium. But now I'm being told, what if you add a base, sodium hydroxide, a base? Remember these are hydrogen ions, this is an acid. If you add a base to an acid, it will react with the acid here. So it will reduce the concentration of hydrogen ions. So if it reduces the concentration of hydrogen ions, the equilibrium will shift to the left, this side. It will favor this side here, forming chromium 2 ions, this one here. But now, okay, when this one are being formed, there will be formation of more yellow, because these ions are yellow in color. But now if you add HCl here, HCl, what will happen? HCl is an acid, so it won't react with the hydrogen ions. Instead, it will increase the concentration of hydrogen ions, favoring the equation to shift to the, or equilibrium to shift to the right side here, forming chromium 7 ions, which are orange in color. So the mixture will turn yellow, not yellow-orange, I mean. This one here, HCl increases concentration of hydrogen ions, shifting the equilibrium to the right, forming more of orange. Now we go to number 10. During electrolysis of dilute copper-2 chloride using carbon electrodes, a current of 1.5 amperes was passed through the solution for 2 hours and 30 minutes. Now we are being told to write the ionic equation of the reaction that occurred at the cathode. So what do we expect at the cathode? At the cathode, we expect to have some solid copper. Copper, solid copper fragments or something. So now, if you expect to have those solid copper at the cathode, it means that the copper was in dilute state, or aqueous state in other words. So you have copper-2 ions here. They will gain ions. If you add 2 ions to copper-2 ions, you'll have copper is solid. That will be the reaction of the cathode. Now we've been given the RAM of copper. Calculate the charge of mass at the cathode now. Okay, change in mass of the cathode. So the charge passed, remember Q equals to IT. Charge passed is equals to current times time. So if you calculate it, we'll give it to be 13,500 coulombs. 13,500 coulombs. Now the moles of electrons, you have to calculate the moles of electrons at the cathode here. It will be 13,500 coulombs. This is the charge passed. All over the original one here, we have 96,500 coulomb. Divided by that. Okay, 13,500 divided by 96,500 will give it 0.14 moles. Now, if you want the moles of copper deposited, it will be this 0.14 we divide by 2 gives you 0.707 moles. And now, for the mass of copper, remember, for you to guess the mass, you have to multiply the moles times molar mass. You have moles as 0.07 times the molar mass of copper is usually 64. If you multiply the two, they usually give it, in fact. Well, in this case, yeah, it's this one here. Molar mass is 64. When you multiply the two, you get 4.48 grams are deposited. Now define the term half-life. Half-life is the time required for half of the radioactive nuclei in the sample to decay. Remember, for the radioactive elements or radioactive samples, you'll get that, okay, radioactive is what do I say? It's a substance. It's like a substance that keeps on decaying over and over again. When now, for example, if you have a sample containing a radioactive material, maybe you leave it today there. The next time you come and find that the radioactive material in that substance has reduced by half, then it will say it's undergone a half-life because half of its radioactive nuclei has decayed. Now, name two particles likely to be emitted when a radioactive nuclei undergoes radioactivity. This one question here. So we have alpha and beta particles. Those are likely to be emitted. And not only this, we also have gamma particles. Gamma particles can also be emitted during such a situation. And now, for the part C of the question, this is the last part of the question, into the whole paper. We've done half of the paper. In the next video, kindly make sure you watch it. I'll name it part 2. Yeah, so make sure that you watch the next part of the paper we're going to complete. But for now, we've covered half of the paper. Let's do this last question. The half-life of a radioactive nuclide is in 3 hours. Given that its initial mass is 288 grams, determine the remaining mass after 12 hours. So it's after 12 hours, but the half-life is 3 hours, meaning within those 12 hours, it will have undergone half-life 4 times. So you have 4 half-lives. If you want to calculate the number of half-lives, you just take the period divided by each half-life, the period of each half-life. 12 divided by 3, you have 4 half-lives. So there's 2 ways to do this question. You can decide maybe you take 288 divided by 2. That's after 3 hours. Then you do this 4 times. It will eventually give you to this 18 grams because for each half-life, it decays to half of its mass. Yeah. So, or rather, because, okay, that takes time. For example, if you have maybe like 30 half-lives, it will take a lot of time to calculate that. So now for the formula, you take the original mass times a half raised to the number of half-lives. 288 times a half raised to 4. That's 288 times 1 over 16 gives you to 18 grams. Use the one that is most convenient with you, but it's good to master the formula in case you get the number of half-lives are too many to calculate. So now, guys, it's been a pleasure with you guys. I hope you've gained something. Yeah, it's just a prediction of KCSE. Most probably the most likely questions to appear in your KCSE 2024. So kindly remember to subscribe. I'll be uploading many videos on KCSE prediction. It's a whole set. So now for you to see the other videos, subscribe so that you may be informed of further videos being posted. And also please comment if there's any area you want clarification. I'll be happy to help, guys. Huh? So it's your guy here. Always happy to help. And see you next time, guys. It's been a pleasure.